All right, today we're going to dive into this incredible microscopic world inside your body. We're talking about its unsung heroes and sometimes, yeah, its most frustrating villains. I'm talking about autocoids. These are the powerful little messengers that are pulling the strings behind everything, from a simple allergic sneeze to that throbbing pain when you stub your toe. And trust me, getting a handle on them is basically the key to understanding how your own body works.
So, here's a bit of a riddle for you. What could allergy attacks, stomach ulcers, and that awful nausea from chemotherapy possibly have in common? I mean, think about it. A runny nose, a burning gut, and feeling sick from a major medical treatment. They seem totally unrelated, right? Well, the answer is pretty surprising. They're all orchestrated by the very same class of tiny molecules we're about to get into.
So, here's the game plan. First up, we're going to break down what these local messengers actually are. Then we'll get to know the three big players, the gatekeepers, if you will. We've got histamine, the main culprit behind allergies. Then there's serotonin, which it turns out is about way more than just your mood. And finally, prostaglandins. These guys are a real double-edged sword when it comes to pain and protection. And to wrap it all up, we'll see how modern medicine has gotten so darn good at controlling all of them.
Okay, let's jump right in. First section, the body's local messengers. Time to meet the autocoids. So, what in the world are these things anyway?
Okay, the best way to think about them is like this. Autacoids are your body's emergency text messages, not its snail mail. You see, regular hormones are kind of like the postal service. They're made in one place, like a gland, and then travel all over through the bloodstream. But autacoids, nope. They're made on demand right on the spot where they're needed for a specific, immediate job. They just pop up, deliver their message to the cells right next door, and then poof, they're gone. It's an incredibly fast and efficient system for dealing with things right now.
And the jobs they do, absolutely critical. I mean, they're the master regulators of inflammation. They're the conductors of the entire orchestra when you have an allergic reaction. They are literally the molecules that send those pain signals screaming up to your brain. And they're also busy in the background controlling stuff we never even think about, like the tone of our smooth muscles or making sure blood flow is just right to keep all our tissues healthy. All right, time to meet our first gatekeeper. And I guarantee you've heard of this one, histamine. Yeah. If you've ever had hay fever or any kind of seasonal allergies, you and histamine are, well, you're already acquainted.
So what happens when histamine gets released? Well, it's basically the script for an allergy attack. First, you get vasodilation. That just means your blood vessels widen, which is why you get all red and flushed. Then it makes those vessels leaky, which leads to swelling. It also causes bronchoconstriction, which tightens up your airways and can make you wheeze. Oh, and it's what's poking your nerve endings, causing that absolutely maddening itch. But, and this is super interesting, it also has this whole other side gig cranking up the acid production in your stomach.
Now, here's the really crucial part. Histamine doesn't just do all this stuff on its own. It needs to plug into a receptor, kind of like a key fitting into a lock. And it turns out there are two totally different locks it uses. You've got H1 receptors. Those are the ones that trigger all the classic allergy and inflammation symptoms. Then you have H2 receptors. These guys are pretty much only in the stomach, and their main job is to get the signal to make more acid. And believe me, knowing this difference is everything when we start talking about how to treat these problems.
And this is such a great story of how medicine gets smarter over time. The first generation H1 antihistamines, the early allergy drugs, they worked for sure, but they had one huge downside. They could cross over into your brain, and that's what made you so sleepy. So scientists went back to the drawing board and designed the second generation drugs specifically to not cross that blood-brain barrier so easily. The result? All those non-drowsy allergy meds that so many of us can't live without today. Pretty cool, right?
So it's pretty logical, right? Two different receptors means we need two different kinds of drugs to block them. H1 blockers are your go-to for things like allergic rhinitis, hives, bug bites, even motion sickness. But if your problem is heartburn or an ulcer caused by too much stomach acid, taking a regular allergy pill isn't going to do a thing. For that, you need a totally different drug, an H2 blocker that's designed to hit that specific target in the stomach.
Okay, moving on to our second gatekeeper, serotonin, or 5-HT. Now, when most of us hear serotonin, we immediately think about mood, right? Like antidepressants and brain chemistry. But get this, over 90% of your body's serotonin isn't in your brain at all. It's in your gut, where it's acting as a really powerful local messenger.
Yeah, serotonin is a real multitasker. It wears a lot of different hats. Down in the gut, it's in charge of motility, keeping things moving. In your blood, it helps your platelets get sticky and form clots when you get a cut. And of course, in the brain, it has that famous job of regulating mood, sleep, and appetite. But, and this is key for our discussion, it also plays a huge role as one of the main signals for nausea and vomiting. So how do you stop that awful feeling? Well, let's walk through the process. Imagine a powerful trigger, like chemotherapy, starts to damage cells in the gut. Those cells freak out and release a flood of serotonin. That serotonin then latches onto a very specific receptor, the 5-HT3 receptor, on the nerves right there. Instantly, that nerve fires off an urgent nausea alert straight to the brain. But, and this is where pharmacology is just brilliant, a drug like ondansetron comes in and acts like a shield. It physically blocks that 5-HT3 receptor, so the serotonin has nowhere to plug in. The alarm signal is never sent. The nausea is stopped dead in its tracks before it even has a chance to start. And the result of this discovery? It's just profound. This was an absolute game changer. By figuring out this local messaging system, we developed a whole class of drugs that completely transformed the experience of things like chemotherapy and major surgery. It gave people powerful relief from one of the absolute worst side effects. Okay, on to our third and final gatekeeper. And this one isn't just a single molecule, it's a whole family called the prostaglandins. And these guys, they're definitely the most complex. You can think of them as being both the arsonist and the firefighter in your body, sometimes at the exact same time. Now, don't get overwhelmed trying to memorize this whole chart. The big idea here is to see the incredible push and pull, the balance of opposing forces. Just look at PGI2 and TXA2 for a second. One of them widens blood vessels and stops platelets from clumping up. The other does the exact opposite. It constricts vessels and promotes clotting. Your body is constantly, every single moment, using this whole family of molecules in a delicate balancing act, just to keep everything stable. And this right here is the central problem, or the genius, depending on how you look at it, of prostaglandins. They're the bad guys that cause all the classic signs of inflammation: pain, fever, redness. But at the same time, they're the good guys doing all these vital protective jobs. They're what creates the mucus lining that protects your stomach from its own acid. They make sure your kidneys get enough flow. They're absolutely essential for a healthy reproductive system. They're heroes and villains, all wrapped into one. Which brings us to a type of drug pretty much everyone has taken. NSAIDs. That's things like ibuprofen and aspirin. So when you pop an ibuprofen for a headache, what you're actually doing is shutting down an enzyme called COX. You can think of COX as the factory that makes all the prostaglandins. Now, that's fantastic for shutting down the bad ones causing your pain and fever. But the problem is it shuts down the good ones too. And that's why taking a lot of NSAIDs for a long time can lead to stomach problems like ulcers. You've switched off your stomach's protection system. But, modern medicine is pretty clever. Instead of always just blocking prostaglandins, sometimes we do the opposite. We give people synthetic versions of them as the medicine. For example, we can give someone a drug called misoprostol, which is a version of PGE1 to help protect their stomach from NSAID damage. We can use latanoprost, a PGF2-alpha analog, in eye drops to treat glaucoma. We can even use dinoprostone to help induce labor. It's all about picking the right tool, the right prostaglandin, for the right job. Okay, so let's zoom out and tie this all together. Let's look at the big picture of how we've learned to get a handle on these incredibly powerful local messengers. And really, this gets to the heart of it all. Modern medicine isn't just about cooking up new chemicals in a lab. It's about being a detective, about understanding the body's own super complex communication network. Once we started to decode the language of these Autacoids, we could design these incredibly targeted drugs that do exactly what we want them to do, whether that's blocking an allergy message, intercepting a nausea signal, or just turning down the volume on pain. And this really brings it right back home, probably to your own bathroom cabinet. That allergy medicine you take, that's a histamine H1 blocker. That acid reducer for heartburn, yep, that's also a histamine blocker, just targeting the H2 receptor. Those powerful anti-nausea meds given during chemo, they're blocking serotonin. And that simple pain reliever you grab for a headache, you're flipping the off switch on your body's prostaglandin factory. See, every time you take one of these common medications, you're basically acting as an Autacoid controller. And that just leaves us with one final, and I think really exciting thought. We've gotten really, really good at controlling these three major pathways we talked about today. But the thing is, there are dozens, maybe hundreds, of other Autacoids and receptors that we're just starting to figure out. It really makes you wonder, doesn't it? As we get smarter and learn more, what kinds of conditions that we struggle with today, things like chronic pain or autoimmune diseases, might become easily treatable with the targeted Autacoid drugs of tomorrow.